So now we're going to discuss the concept of magnetic force. Sometimes it's also called the Lorentz force. Now, in the previous lecture, when we discussed the electric field, we know that if you have a charge and then it's in the electric field, then this charge will experience an electric force. What happens if you have a charge in the magnetic field? It turns out that the charge in a magnetic field will also experience force only if the charge is moving. And the force acting on the charged particle in a magnetic force is given by the Lorentz force, which is Q, the charge of the particle, V, the speed of the particle, B, the strength of the magnetic field, times sine of the angle theta, which is the angle between V and B. So it is the angle between the velocity of the particle and magnetic field B. Now in this expression, it is important to realize that Q, the charge of the particle, it can be positive or negative. And if it's a positive or negative, the sign of the force will change accordingly. So this is the magnitude of the force. Now how do we find the direction of that force in the magnetic field? Well, to find the direction, we're going to need to use our right hand rule. Okay, so you have to take your right hand and then point your index finger, in the direction of the velocity. Your middle finger is in the direction of the field, and the thumb will then point in the direction of the magnetic force. So again, index finger, velocity, middle finger, magnetic field, thumb is the force. So let's look at a few examples. Let's say that we have a magnetic field, a uniform magnetic field pointing to the right, and then a positive charged particle moving down. So the magnetic field and the charged particle are perpendicular to each other. The velocity of the particle is perpendicular to the magnetic field. So in what direction will be the force in this case? Well, let's use our right hand rule again. So V is pointing down, index finger, right hand. V is pointing down. B is pointing this way. So force is pointing towards you. So the force acting on this particle will be pointing out of the board like this. So if I want to label the force pointing out of the board, I will just put a circle with a dot. So this symbol is symbolizing that something is pointing out of the board. Now let's look at a few more examples. Let's say that the magnetic field is pointing into the board. So the magnetic field is pointing into the board. Velocity of the charged particle is to the right. What is the direction of the force? Again, index finger pointing this way. Middle finger, the magnetic field, is pointing into the board. So the force is pointing up. The force is pointing up. Let's look at another example. Let's say that the magnetic field is pointing out of the board. Velocity V is pointing up, and it's a positive charged particle. Again, we use the right hand rule. Index finger along the velocity v pointing up. Middle finger is pointing out of the board. So F is pointing this way. So F is pointing to the right here. Okay, so in all of these examples that we looked at, our particle was positive. So what happens if your particle is negative? So let's change the sign of the particle. For example, in this example, the particle is now negative. Now all you have to do is you first have to find what is the direction of the force acting on a positive particle, and then simply reverse the direction. So for example, we already found that in this particular example, when the particle was positive, the force was pointing up. So for a negative particle, the force would be pointing down. Same thing is here. If I change this now to negative, the direction of the force will reverse. Now let's look at a few special cases. Let's recall our expression for the force. Force is equal to QVB sine theta, where theta was the angle between V and B. What happens if the magnetic field and the velocity of the particle are in the same direction? In other words, if theta is equal to 0. Well, in that case, you can see that the force is also equal to 0. The same thing is true when the velocity of the particle is anti-parallel to the magnetic field. In other words, it's pointing in the opposite direction. Well, this means that theta between the two is equal to 180. But sine of 180 is still 0, so you get force equals 0. So the conclusion is, when the charged particle velocity is along the magnetic field, parallel or anti-parallel, it experiences no force. And now, one final note. We said that we use the right hand rule to find the direction of the force. Index finger V, middle finger B, force F for a positive particle. So if I say that this is my velocity, this is the field, they can be at any angle. They don't have to be perpendicular, they don't have to be parallel, they can be at any angle. But the force will always be perpendicular to these two vectors. So these two vectors, they create a plane. But this force is always perpendicular to that plane.